Now my next question is the largest value of non-negative integer a for which limit x tends to 1 minus ax plus sine x minus 1 plus a by x plus sine x minus 1 minus 1 to the whole power 1 minus x by 1 minus root x equal to 1 by 4. You have to find out the value of a. So here you see that this the only formula which can be applied in this question is that sine x by x. This is the only formula you can apply here, and this is a very easy question. Only here there is a slight setting is required. Only a slight setting is required. Here you see that limit x tends to 1. Here you see a minus a common. Here you see this is minus a common, and then x minus 1 plus sine x minus 1 x minus 1 divided by, here this is x minus 1 plus sine x minus 1 and this 1 minus x by 1 minus root x is equal to 1 by 4. Now, as it has been you are taught earlier that you place the value of 1 on the numerator and denominator. If it is 0 by 0, then you have to do some arrangement so that you do some arrangement to solve it. And the first procedure that most of them apply is the L'Hospital rule. Differentiate the numerator and differentiate the denominator. So here what is the problem here is that you can differentiate the numerator as well as the denominator. You can do that, you can apply the L'Hospital rule, but this the power here, this power here, this power, because of this power because of this power it will be not you can't apply this L'Hospital rule because of this power. Here this is the power. So to solve it you have to do some arrangement. You will have to do some arrangement. So here you have come to know that why L'Hospital rule can't be applied, because if it was only like this, something here and something here, then you differentiate the numerator and the denominator, then you can apply the L'Hospital rule. But here one thing is that this power, it blocks everything here, because this is the power. Because of this power you can't apply this L'Hospital rule here. It is better that you have to go for some arrangement. So here I have made some arrangement. Here you see that now limit your x tends to 1. Here you see you take x minus 1 common here, so it will be minus a plus sine x minus 1 by x minus 1. And now again in the denominator also you take x minus 1 common, so this will be 1 plus sine x minus 1 by x minus 1. And now, and as a whole, this whole, here you can make an arrangement, that is 1 minus root x the whole square by 1 minus root x is equal to 1 by 4. So this is a square minus b square, so a plus b into, so this will be 1 minus root x into 1 plus root x divided by 1 minus root x. So this cancels out and it will be 1 plus root x. You will get 1 plus root x. So here again you see this cancels out, and here you see this sine theta by theta, theta tends to 0. This will be 1, this will be 1. So the remaining that will be left with you will be limit x tends to 1, and this will be minus a plus 1 divided by 1 plus 1 to the whole power 1 plus root x, that is equal to 1 by 4. Now now you can apply, you can release this limit. Now you can release this limit here. So when you release this limit, it will be like this, minus a plus 1 by 2 to the whole power 1 plus 1 2, that is equal to 1 by 4. So now if you take square root, you can take square root both side. You can take square root both side. If you take square root both side, So this will be equal to minus a plus 1 by 2, that will be plus minus 1 by 2. So for minus a plus 1 by 2, if you take this will be minus a plus 1 is equal to 1. So here your minus a will be 0, so a will be 0. And another possible value is that minus a plus 1 by 2, that is equal to minus 1 by 2, minus a plus 1 is equal to minus 1. So minus a will be minus 2, so a will be 2. So these are the two possible values of a. So here you see that when it is 0 by 0, why I am not able to apply this L'Hospital rule, and here you see that I have to make some arrangements. So this is the arrangement. So here only the formula which is applicable here is sin theta by theta, limit theta tends to 0. So this becomes very easy. Very easy to solve it. And the most important thing here is that you try to minimize the term. The more you can try to minimize the term using the formula, it becomes more easy to solve the problem.